Hi there, I thought I'd talk you through differentiating y equals log of sine x. And this is a special case of the differentiation of the Russian doll situation or composite function, because we're going to get an interesting result out of it. So, yeah, we've got two functions. The function inside the Russian doll, if you like, sine x, and then outside of that, the bigger Russian doll, log of it. So effectively kind of log of x. So to differentiate this, we're going to need to first of all define u as sine x and differentiate that. So du by dx, that's cos x. And once we've done that, we now have to define y as log u and differentiate that. So dy by du of log u is 1 over u. So we end up with cos x and 1 over u, and to get dy by dx, we just need to multiply those two together. So dy by du times by du by dx. So multiply those together, we're going to get cos x over u. But u is sine x, isn't it? So we can just change that to sine x. And when you see that, you notice that on the bottom is the original function, the original Russian doll one, if you like, sine x, which is what we'd expect because it was 1 over it. And on top there is its derivative. So we get this interesting thing that whenever we integrate a function where the top of the division is the derivative of what's on the bottom, we should get log of this. Like we should just return to this, so log of this. So if we look at that, if we integrate cos x over sine x, it should just be log of sine x plus c. And an interesting way of looking at that is if I replace it with any function, that's the derivative on top, so e to the x, differentiate that, I get e to the x, then integrate that, that should give me log e to the x, right? But log e to the x is equal to x, because I bring the power down, and as using the log rule, then it's just log e, and log e is 1, because it's the same base, e to the power 1 is e, so we just get x for that one, and so therefore x times log e plus c is equal to x plus c. And that makes sense, because e to the x divided by e to the x is just 1, isn't it? So effectively the integral I just did was the integral of dx, which is the definition of integration. The sum of all the little x's makes x, plus your starting point of c. So I hope that was of some use to you, and try a few more examples like that.